Oops. Sorry. Let's go on to section 10.2. Oh, I wonder, can you guys still see the writing in the background? Say yes if you can. Can you see this in the background? Yes. Okay, good. Wait 1 second. Let me get rid of that. Okay, so let's go on to section 10.2, multiplication and division of radicals. So let me do on page 414, problem number 4. So, well, first off, you should remember that if I have, this is one of the properties of exponents. If I have a base to a power times a different base but to the same power, then if I multiply these, I just multiply the bases together and raise them all to the same power. Therefore, if you have two radicals that are the same and you multiply them, then all you have to do is multiply the radicands together and just take the same radical. Okay, so let me do on page 414, problem number 4. In exercises 1 through 24, use the product rule to write the expression under one radical. So the square root of 3 times the square root of 5 is the square root of 3 times 5, 15. And that's your answer. So if you happen to have the same exponent, the same index here, in this case the index is 2, and I'm multiplying, then you just multiply the radicands to get your new radicand and keep the same index. Let's do problem number 10. The 4th root of 3 times the 4th root of 11. Since the indices are the same, they're both 4, this will be the 4th root of 3 times 11, 33. Let me do problem number 24. The 6th roots of 32, a to the 4, times the 6th root of 2a squared b squared c. So we both have the same index c. Let's multiply the radicands together. And so this will be the 6th root of 32 times 2, 64. A to the 4 times a squared, a to the 6, b squared c. Well, I can determine the 6th roots of 64. The 6th root of 64 is 2. The 6th root of a, well, these indices are the same. So the 6th root of a will be a times, well, the 6th root of what remains, b squared c. Now, I sort of lied. The 6th root of a to the 6 is not actually a. It's actually equal to the absolute value of a. If you happen to have an even index, then when you take, the nth root of a to the n, when n is even, is really equal to the absolute value of a. The nth root of a to the n, when n is odd, will just be equal to a. But if you have an even index, which in this case is 6, when you take the 6th root of a to the 6, you actually get the absolute value. So unless we specify that the variables are non-negative, then we really need to put in an absolute value here. Let me do problem number 30. In exercises 25 through 40, use the quotient rule and simplify. Okay, so I have here the 4th root of a, b to the 4, over the 4th root of a. So I can just make this one big radical. The 4th root of a b to the 4 over a. A's cancel. So I find the 4th root of b to the 4. I have the same index. And so this index cancels this power. And so the 4th root of b to the 4 is b. Now, if they have not specified that b is greater than 0, then I have to put an absolute value here. And so the absolute value of b is the same as the 4th root of b to the 4. They did specify that a was greater than 0, but they did not specify that b was greater than 0, so I need the absolute value. Let me do problem number 42. In exercises 42 through 70, simplify the radical. Okay, so now I have here the square root of 12. Wow, now they're saying to simplify it. I know how to simplify like the square root of 16 or whatever. How do I simplify the square root of 12? Well, let's write 12, the radicand, as the product of two terms, one of which is the largest perfect square factor. And so let's write 12 as 4 times 3. And so the square root of 4 times 3 is the same as the square root of 4 times the square root of 3, but the square root of 4 is 2. And so I have 2 rad 3. Let me do problem number 46, the square root of 147. Well, I can write 147 as 49 times 3. The square root of 49 is 7. And so the square root of 147 is 7 rad 3. Let me do problem number 54. The cube root of negative 270. Let me write negative 270 as negative 27 times 10. Well, negative 27 is a perfect cube. It's the largest perfect cube factor of negative 270. The cube root of negative 27 is negative 3. Therefore, the cube root of negative 270 is negative 3 times rad 10. Let me do problem number 64. The 4th root of negative 27 times 75 over the 4th root of 25. Well, negative 27 times positive 75 is a negative number. Negative times positive negative. The 4th root of a negative number is not defined. And so I have something that's undefined divided by, well, something that is defined is still undefined. And so this whole quantity here is not yet defined. And so that's your answer. This is just not a defined number. Let me do problem number 70. The square root of 50 times the square root of 60 over the square root of 30. So let's just take the square root of 50 times 60 over 30. Well, 60 divided by 30 is 2, times 50 is 100. The square root of 100 is 10. Let me do problem number 74. And so, let's find the, let me just see something for 1 second. 1 second, sorry. 10.3. In exercises 71 through 103, perform the indicated operations and simplify Variables represent positive numbers. Okay, so problem 74. The square root of x cubed y to the fourth. So in this case, we don't have to worry about negatives or anything. All the variables here are positive. And so let's write x cubed as the product of a perfect square times whatever. Well, it turns out that what is the largest multiple of 2? That's less than 3. Well, 2. So let's write x cubed as x squared times x. X to the fourth is already, well, 4 is already a multiple of 2. So the square root of x squared is x. The square root of y to the fourth is y squared. And we have times the square root of x. And so the square root of x cubed y to the fourth is just x y squared times radical x. Let me do problem number 84. The square root of a to the 10. Well, 10 divided by 2 is 5, so the square root of a to the 10 is a to the 5th. 96. The square root of 12, a cubed b, over the square root of 24, a squared b squared. This is the same as the square root of 12, a cubed b, over 24, a squared b squared. 24 divided by 12 is 2. A cubed divided by a squared is a. B squared divided by b is b. So this is the same as the square root of a over 2b. Let me do problem number 103. The cube root of 2 a squared b cubed times the cube root of negative 4 a to the 5th b to the 9 over the cube root of 64 a squared b cubed. So this is the same as the cube root of 2 a squared b cubed times negative 4 a to the 5th b to the 9 over 64 a squared b cubed. 2 times negative 4 is negative 8. A squared times a to the 5th is a to the 7. B cubed times b to the 9 is b to the 12 over 64 a squared b cubed. 64 divided by 8 is 8. A to the 7 divided by a squared is a to the 5th. B to the 12 divided by b cubed is b to the 9. So I want to determine the cube root of a negative a to the 5th b to the 9 over 8. Let me write a cubed as, a to the 5th as a cubed times a squared. B to 9 is already a perfect cube since 9 is a multiple of 3. The cube root of a negative a cubed is negative a. The cube root of b to the 9 is b to the 3rd. The cube root of 8 is 2. Therefore, this is equal to a negative a b cubed times the cube root of a squared over 2. And that's your answer. And so that finishes off section 10.2. Let me go on to section 10.3. Okay. And everyone